All right, welcome everyone to our first Bicep Community Call of 2022. We have some cool information we're going to cover today, which is the Bicep Codebase walkthrough. It's going to be at the end, so we'll have questions and answers after regular updates, and then take the rest of the time talking about the walkthrough. And any questions you guys have, please put them in chat. We might not have time to all answer it on mic. All right, so here's our team, nothing new. Our maintainers as well. We appreciate you guys so much, always, as always. How to communicate, like I said, use the chat, talk to each other, ask questions. We have our engineers in chat, always looking out for questions. What is the community call for? It's for you guys. Get updates on topics we might not otherwise cover. Be active, and this is more of a casual connection with our communities. Of course, we just want to talk to you. All right, so we just want to update you guys, just remind you guys what the future releases are going to be. Nothing super new. Alex, do you want to give a quick update on this? Or?
Nothing major other than it's as with most things, the public registry is taking us a little longer than we would have otherwise liked. So what we thought was going to be released in January, we're hoping now will be released in February. But we've got some good momentum here. We're feeling pretty confident on getting that piece out for 0.5, and then we'll be jamming on and working towards 1.0. I think one change you will see that we're kind of working out the details of is having kind of clearer monthly releases, similar to how PowerShell and Azure CLI and some other services do it. So we don't have this kind of big build up to a particular release. We just, like, every month we'll cut 0.5, 0.6, 0.7, 0.8. We will declare a 1.0, and we've gotten some particular things done that are listed here. But we want to have a more reliable cadence and smaller backlogs that are easier to track for us and for you all in the community. So after 0.5, just because we've communicated pretty clearly that 0.5 is going to have this public registry in particular, we'll switch to a monthly cadence that'll be just easier to keep track of.
Thanks, Alex. All right, Joshua?
Yeah, thank you. Hi, everybody. My name is Josh Waddell. I'm a engineer over in Fast Track for Azure. And just wanted to talk real quick about some things that we have coming from a learning perspective around Bicep. So some of you may know that last year there was a series of 14 modules published to MS Learn in 3 different learning paths, one on fundamentals of Bicep, intermediate Bicep, and advanced Bicep. Additionally, 2 learning paths focused on using Azure pipelines and GitHub Actions were published to MS Learn as well. I'm going to be putting the links to these here in the chat shortly. But as a result of those modules last year, we were contacted by Learn Live, and we are currently putting together a series of episodes based on all 14 of the original Bicep modules from MS Learn. The presenters are going to be a mix of cloud advocates, some of the team here, as well as some engineers for FTA. So just kind of previewing it here. Nothing really to show you in terms of slides or anything, but in the next community call, we'll have some more details for everybody. It is going to be starting March 10th is the initial time slot at a 10:30 PST. Is going to be our initial time slot, and it'll run for the first 2 modules leading up to MS Build. We'll take a couple of weeks off for MS Build and then resume with the final learning path there. So if you have any questions on this, feel free to drop them in the chat, and I'll send some links here in a second. So thanks for letting me speak.
Thanks, Josh. All right, Uche.
What's up, everybody? My name is Uche. I'm one of the PMs on the Bicep team. Yeah, so we're having some customer chats going on because we would really love your feedback to improve the Bicep Doc, if you just want to answer some questions, understand what kind of docs user you are, what are some common scenarios that you and your team would really enjoy seeing within the docs, and just organizationally, what helps you navigate the best. So spots are going fast like hotcakes, and we would love for y'all to sign up as soon as you can. It's going to be at aka.ms/Bicep Doc Talk, DOC Talk. So sign up. We have a good amount of the community members that have already signed up, which is really awesome. It's getting the documentation team super excited. So we would love for as many of y'all to sign up as you can. If you're interested in chatting with us for like 30 to 45 minutes on ways that you would want to improve the docs, as well as just understanding how do you use the docs and what do you do with you and your team as a way to be successful in Bicep. So check it out, please sign up, and we're excited to get engaged with each and every one of you.
Thanks, Uche. Yeah, we're super excited to talk to you guys about doc improvements or how you guys feel. Hopefully it's good and positive, open to the negatives. Okay, Bicep updates. Bryson?
It took me a little longer to get on the turn on my mic, but here I am. Okay, so we made some progress on the investigation into the anonymous access. It looks like conversations with the SDK team, like we're using an SDK to talk to Azure Container Registries today. We had some good conversations with the SDK team, and we feel like the most likely outcome is that we will just make it work transparently. So there will be no, if you want to interact and pull artifacts with from anonymous registries, it'll just work transparently. You won't need to have any extra configuration. We won't have to change the configuration schema or anything like that. That's kind of our plan there.
Marcia, are you speaking through the other ones, or did you guys want me? I forgot who was covering this part of the
We
slide.
ended up, I think we just want to have an open discussion on the versioning. I don't think we've done any investigation today, up to like as of today, about like what the best practice is for versioning modules. So we're kind of curious how everyone in the community is just doing it these days. What are your approaches? What's working? What's not working? Be good to hear. Either have some people come off the mic, like come off mute and basically talk about it, or just talk and chat if it's easier and more comfortable.
And then I think Shenglong, you were going to give an update on What If, right?
Yeah. So for What If, we know that there's a feature request that the community wants us to implement, which is basically being able to resolve reference function. So this is affecting Bicep users because the Bicep generated JSON template contains a lot of nested deployments and lots of reference functions. So as a result, many resources will be missing from the What If result. So we've been trying very hard to implement this feature. It's kind of a gnarly feature to implement, so it did take us a long time to implement it, and we tried to make it public before, but unfortunately we just discovered several small issues, which was fixed recently. So the feature is now checked in, but we're still waiting for it to be fully deployed, and we're expecting it to be deployed by end of February. So hopefully everyone can use the new feature at the time. Yep.
And then so for the other three things we have here, we have ability to use getSecret in a conditional way. For that item, we'd really like to collect some feedback on firstly just how important it is to people. So if you've run into this and you'd like to see it implemented, then we'd really like to just get some thumbs up on the issue, and also just kind of have a bit more information about the sort of scenarios that you're running into for this. So if someone could paste a link actually to that issue in the chat, that would be great. For copy index, again, this is this is a bug that I think we haven't really done much investigation into. So again, I think just getting some feedback on that would be really good to help us prioritize it. Finally, for issue 146, that's a pretty old one, multi-line support. What we're currently thinking with this is we'd like to kind of understand some areas to target with this. So rather than just getting rid of new lines completely in the language, like think about what is frustrating to people today. So I would like to collect some feedback from people on, for example, do you find the lack of multi-lines and functions annoying? Do you find it would be really useful to be able to put an object or an array on a single line? Are there any kind of specific scenarios that you'd like to see us target there? And feel free to put your feedback in the chat or respond to the issue as well.
We do have some questions in chat.
Would you mind reading them out, Stephanie?
Sorry, yes. For the what if / skipping resources, will this cover nested modules and looped resources that currently are not shown?
Yes, that's what the fix is for.
Oh, yes, you guys responded in chat. Awesome. And Pinaki, you have your hand up?
Yes, guys. I'm Pinaki here from Netherlands, Microsoft. Just a quick feedback I wanted to share. I've been promoting Bicep to many of my customers, also to my internal colleagues in Microsoft with managed IP and workshops and those kind of things. So I've been getting very, very good reviews. One of the feedback I got is that what is on the landscape to enable or support conditional properties, not just a resource tag, but within it. And I did find it could be very handy when you're deploying something like NSG rules or even like firewall policies into landing zones, because everybody's now using landing zones. So conditional property within a resource.
So we do have the ability to use the ternary operator to say that the property value based on a condition should be either this or that. And you can say if it's true, it should be whatever value. And if it's false, it can be null, or it can be an empty string. Sometimes you need to do. The challenge is that not all resource providers handle that null property in the same way. Ideally, they would treat it as basically the equivalent of the property not being included at all, but not every RP handles it correctly or in the way that at least that we would like. There is an outstanding issue, and I'm trying to find the link for it, to skip an object property based on a condition, which is something that I think we'll eventually need to implement for this reason. So that's a good one to upvote. And that I think will get you what you're looking for, Pinaki. Does that sound right?
Yes, partially, Alex. What I'm missing is that if I put ternary, right? So you can have what I do get is an if then. So if something falls true, do this, otherwise do this. So what I do miss is what about an else? And I'll give you a best example. I have an API management, which I'm now going to instantiate, which I've been doing a lot, either internally or externally onto a VNet. So you got a Boolean variable, say, okay, internal. If the Boolean is not there, internal, external. The else part, which is my default behavior, is missing.
I don't know if I'm following. It might be good to review it offline, because the else is the third argument of that ternary expression. If it's true, okay, do this, else do that.
Okay. I'll loop up with you, Alex.
Okay, that sounds good.
Maybe I'm missing something, no worries.
Okay, cool.
Thank you.
Thank you.
Any other questions on the Bicep updates that we need to cover, Stephanie?
Nope, that's all. I think we just want to get more information from people, what they're looking for, versioning modules, be more specific, like Marcin said. Yeah. Otherwise, we can go into questions and answers. We have a couple of questions in chat. Anyway, let's see, is there a plan to support?
Sorry, before we,
Yeah.
sorry for cutting you off,
Yes.
Stephanie. Before we go to questions, just one more point on the versioning stuff. When we do have the public registry, I think I mentioned this in one of the discussion threads, we will have workflows we will have a versioning strategy. So we will have the ability as modules change to up the versions, and we at least have a system that we think will work to start, and we'll adjust from there. But all those workflows will be public. So basically you'll be able to take the same CI processes and automation processes for how we version, how we check for new versions and all that sort of stuff, and integrate that into your, at least your GitHub workflows if you want to use that. If you want to use pipelines, at least you'll have the conceptual processes and some of the scripts that we're using if you want to do it there as well.
Yep, thanks, Alex. If anyone wants to raise their hand or come off mute to ask questions, that'd be great. Let's see.
May I pose a question? Hello, everybody.
Hello.
Okay, so recently, I initially was using Bicep quite a lot back in 03. Tried lately to on an existing, let's say, repo I had, and I saw that I got warnings exposing secrets on the output of a module. I found it really good reasoning, let's say, not to do so. But what would be the best option? Let's say generate a resource and get on the same deployment the let's say connection string to be included in a key vault, let's say secret value. What would be currently the proposed way doing so?
Well, one thing I would consider with that. Oh,
go ahead, Brian.
One thing you can consider with those, Nicholas, is rather than outputting the secret and then consuming the secret later on, is output the resource ID and put your request for the secret in line in the properties body where you need it. And so that would be the simplest way to do it. If you wanted to go in and stuff it in a key vault, you could do that, but then that means you'll have to have permission to deploy to that vault. If it's in a different resource group, you have to pass in parameters for that. It's a little heavyweight, unless you need to kind of reuse that and store it in key vault. I wouldn't go that route. I would just move your request for the secret to where you actually need to consume it. Does that make sense?
Oh, yes, but I think I got a warning when I was trying to create to get a secret a reference out of the ID only. I remember I was getting a warning at least compile time. I didn't try to build it.
What's the secret? What's the secret, Nicholas?
The secret was from Rediscuss, but the same thing would be I was trying to do with a storage account as well. But thanks, I will try it out and think if let's say I have
and feel free just to shoot a template to me in email. Don't spend a ton of time on it if you're having trouble. Just shoot it over because we've been through the scenario a bit, so it should be pretty straightforward.
Okay, thank you very much. Thank you.
And then just for whatever it's worth, if you're consuming that secret in or your desire is to consume that secret in another Bicep file. So if you're creating the storage account in one module and you want to get the secret in another module, you can use the existing keyword in that other module. So just like Brian's saying, emitting the information you need in the module, and then in the parameters of the other module, you receive those, basically reestablish the reference to that resource, and then get the secret from there.
Okay, good point. Okay, thank you. Thank you, Alex.
Kevin, you have your hand up?
Sure, thanks. So I want to bring up something I've seen posted before in issues, but I don't think I've seen a resolution for, but trying to deal with some nested for loops within inside of, say, like the property section for a resource. I spent actually the last 2 days trying to sort out how to get something jury rigged so that I could get it working, and it was very time consuming. I'm just curious if there's been any discussion or any more talk on trying to provide ability to do nested for loops within inside some of the resources?
I don't know, Marcin, if you want to comment on that. I think we need to spend some time investigating what can be done there. I think we think it can be done. We just haven't had the time to work on it at this point. You're muted, Marcin.
Pretty sure. I guess I double clicked it. Yeah, I think you're right. I think you're right, Alex. Like we're pretty sure that we will be able to support nested looping through like nested resource loops without having to make changes to the basically to the runtime, because that's usually the most expensive part of making any Bicep changes. We just have to investigate and make sure that there aren't any unexpected cases where that approach will break. We're pretty sure it'll work, but we have to kind of do our due diligence there and confirm, and then we'll be able to basically make the Bicep change to support that. Okay,
and then so that would cover, say, if I'm looping over, I'll just throw auto scale settings. I'm creating profiles, and each profile has sets of rules. So I have a loop for every profile, and then a loop for each of the rules going to each profile. It would be able to handle sort of a scenario like that.
I think so.
Okay.
I think we're talking about nested property loops, right?
Yes. Yeah.
Oh, nested property loops. I missed this part. I thought we were talking about resources.
Oh, sorry. Yes. No. This would be for nested property loops within inside of a resource. Instead of having to, in this case, I have to create a module and then pass it into it that way. Being able to, I mean, there's plenty of properties out there where you end up having to pass arrays in. It would be
in
great
that case
to make that work if possible. If it is,
yeah.
I don't know.
In that case, I think the approach, so the approach I described would only work for nested resource loops.
Okay.
Having nested property loops will require a runtime change for sure. Right now, we don't. I don't think there's any trick that we could do to avoid it on the Bicep side. But it's. I don't know if we have an issue open for it. Have you opened one?
I have not, but I will open one specifically around like the nested property loops.
Yeah.
So just the example of what I worked through.
Yeah.
I think we do have one somewhere. I'll try and dig it up.
Oh, okay.
Yeah. If we do, then please just paste in your example into the issue as well. It'll help us prioritize.
Okay, will do. Thank you.
Thank you. All right, Alex Nahas.
Yeah, it's Nahas. Hi, everyone. I have a question about the public registry and concerns in my client about supply chain attacks. Are we thinking that there's going to be a way to preclude use of external modules completely? Is that on anyone's radar? And you don't want to have to rely on something like check marks to detect that. And this particular client would never permit an external module of any kind to be deployed into its Azure environment. So I'm just wondering if that's been a discussion among any of the community members.
I mean, we've definitely discussed the concerns of supply chain attacks, and I think part of the reason why we bet on ACR is they have the exact same problems at a much larger scale than we'll ever have. So from a technology standpoint and distribution standpoint, we've definitely considered that. But for the specific request of blocking the use of external modules, I don't know, Marcin or Anthony or Shenglong, if we've discussed that up to this point, but it is a good thing to think through.
We have not discussed it. I don't remember ever seeing an issue about that particular scenario. So it'd be good to open one if you can.
Yeah, I'll do that. I just want to point out that public registries are not an unalloyed good, and so we have to think about that. If you think about the risk, I mean, it might be far-fetched and an edge case, but we are talking about deployment into an Azure environment here. So yeah, I'll open an incident and we can discuss it. But I appreciate you guys letting me put it on the radar.
Yeah, no, I mean, I think the concern is definitely valid. Like internally, we have internally at Microsoft, we have policies that usually operate on, like, for example, pulling in NuGet feeds. We will usually use our own internal feeds. They are mirrored off of like public feeds after some scanning and other operations. So that's definitely something that we will need to consider. As far as workarounds go today, we do have the ability to, like, once the public registry becomes available in 0.5, we will let users remove the public registry as a source of modules by changing their config. So I think it'll be just a matter of enforcing that nobody ever adds it back in into the configuration file. Because once we do that, you will not be able to pull from any public registry other than the ones you have configured. And if you've configured no registries, then you will not be able to pull external modules, basically, and you will have to rely on local modules. So that is definitely possible to do today. The only, I think, piece that is missing is the enforcement or blocking of re-enabling the functionality or reconfiguring, which will be kind of an interesting scenario to think of, but it's something that I think we'll have to do.
Yeah. So appreciate that. Just consider a client with that operates in consider an Azure user who operates in 130 countries with development teams in each of those countries. Right? Yeah. So that's the scale I'm talking about. And locally is not, the security people will, they'll have a problem with being able to enforce that. So let me, I put it out there. Look forward to the discussion.
Yeah, for sure.
Wouldn't a private container registry, Azure Container Registry, and a private build server fix that issue? And not allowing the public access to public container registries?
Maybe it's scale that I'm concerned about. I'm trying to prevent amateur developers, not amateur developers, but beginners. People that are well-meaning but are not security conscious from blundering into using a flawed module.
Question in general, though, when you compile when you use Bicep to compile using a private or a public registry, does the ARM template have references to that, or is the ARM template monolithic? I mean,
the ARM template is monolithic, like it's a self-contained template that has all the modules resolved. Right.
So there's no way for your deploy to actually know that it came from a public registry.
Correct.
If we don't have those artifacts in there, it's not there. Even if you deploy it using Bicep, even if you deploy the Bicep file, isn't ARM in the background compiling it into an ARM template before deploying it?
It's actually not even ARM compiled.
That happens client side
before it even reaches ARM. So yeah, we need to think of a client side solution to the problem for sure.
Yes, because Azure can't block this.
Correct. Yeah, I think Alex, if you can open up an issue and everyone should comment on that. I think this is a really good discussion to have, and there's probably a few different options to think through.
Okay, we'll do. Not today though, but we'll do.
That's okay.
We only have time for one more question. Joe Robbins. And anyone else can just put their questions in chat and we'll definitely get to them.
Yeah, and I'm sorry, I can't put this in chat because for some reason I don't have the chat. But is there any plan to support string interpolation in parameters coming from parameter files? Because I ran into, like, some of my templates have had to be unnecessarily complicated because I could not use variables in the values I'm passing in.
I think that would be a really good one to share on the, we have the issue for bicepifying the parameters file. I think that'd be a really good piece of feedback to share there, because I think that's one really good benefit of us moving away from JSON and supporting our own format there.
And I couldn't find, I thought previously I'd found an issue on this and I couldn't find an issue now.
Yeah, I'm just going to put it in the chat. This is just the general issue for supporting like Bicep referring the parameters file essentially.
Can you, for some reason, I don't have the chat on my Teams. Can you just tell me what the issue number is?
Issue 399.
399, thank you.
So yeah, it'd be great if you could put that particular scenario or use case down into that issue.
Thanks.
Thanks, Joe. We can probably answer one more. Chris, I know you had your hand up for a while.
Nope, clear me.
Okay, sounds good. Cool. So then we could move on to the Bicep Codebase walkthrough. Anthony, you want to start?
Yeah, so I'll just start sharing. So this is going to be me, Martin, and Shenglong just kind of giving you a quick overview of the various pieces that make up the Bicep Codebase and how it all fits together. Okay. Can you see the screen?
Yep, we can see it.
Okay. Just figure out how to move it. Is that an okay size as well? I'll take that as a yes.
Yeah,
okay.
Size looks good.
Okay. So yeah, this is really just a very quick overview. It's pretty hard to fit like as much detail as we'd like to give into this talk. So really, just anyone looking to contribute to Bicep, this really kind of just should give you an intro, should give you the kind of the rough parts of the code base to look into. And obviously, like if you want any more information, we can always like follow up later and provide more information about how different pieces work. So yeah, this is really just a high level picture of the components and how they fit together. And while I'm talking, please feel free to interrupt me or stop me for questions, or type in the chat and someone else can mention to me anything that you'd like more detail on. And the other thing to note is we actually, as part of preparing for this presentation, we've actually written up this whole doc, so you can actually access this documentation in the Bicep Codebase itself. So if someone could share a link to that as well, that'd be useful. Okay, so the first thing we have here is just the overall compiler structure. Here I've kind of drawn the kind of end-to-end of converting a Bicep file into JSON. We start obviously at the top with a Bicep file, and we end at the bottom with a JSON file. And the two interesting things to note here are the components that we have. We have the CLI, the Bicep CLI. So the Bicep CLI obviously is concerned with just taking your Bicep file and spitting out an ARM JSON file for you, or raising diagnostics and failing the build, depending on what's happening. So we have this parsing, binding, semantic analysis, and emitting phases. These are the various phases of the compiler that the CLI runs through to produce that output. So for the CLI, it's pretty simple. We just kind of run through this pipeline from start to finish. We want to make sure we can parse the file. We want to make sure that everything's valid in the file. And then we actually want to do the generation as part of the emitting phase. The language server is what's running in your VS Code extension. It's actually sharing the exact same code, so it's calling into the same library, but it's able to kind of speak to these various different phases independently. So, for example, if you open a Bicep file and the first thing you see is just the colors of all the different elements, like the resource keyword is purple, for example. This is all coming through a request. Semantic token colorization request that the language server makes to the parsing API. So the parsing API itself is able to basically do that job, and so the language server doesn't have to run through this whole pipeline every time you're typing in the editor. And there are various different requests that the language server can make. We go into a bit more detail in at the end of this document about what those different types of requests are. But the gist of it is it kind of like does the minimum amount of work needed to produce the response. So colorized document isn't going to trigger a whole compilation of the JSON file. It's just going to parse the document and give you the tokens. Some other examples are if you hover over a variable in Bicep, we show you a display. That's an example of something which I think is mostly touching the binding APIs, which we're going to talk about a bit later. Similarly, when you make changes to a Bicep file, you see diagnostics, you see squiggly lines, you see errors and warnings and things like that. That's again all coming through this get diagnostics API or publish diagnostics API that the semantic analysis portion of Bicep is returning. And generally, the language server doesn't really do anything with the emitting phase. We don't actually build the Bicep file itself, or the JSON file itself as part of the regular editing. Okay, so just to go into a bit more detail about these various different black boxes, the parsing phase, that's the first phase. So we're taking in a stream of characters, which is your Bicep file, and the first thing we do is we lex it. The lexing phase basically looks at your stream of characters and tries to identify the tokens in that stream of characters. So for example, if you have 1 plus 2, you'd have a token for the 1, you'd have a token for the plus, and you'd have a token for the 2. And so the lexer, which we have a link here to the lexer, is really just responsible for going from the start of that file to the end of that file, pulling out the tokens, and presenting a stream of tokens that the parser can then consume. So as part of this parsing phase, we first do the lexing. The next part of the parsing phase is the actual parsing. We have this parser class, parser.cs, and this is a handwritten recursive descent parser. And what it does is it does something quite similar. It kind of iterates across the tokens produced by the lexer. So in the case of 1 plus 2 here, it's going to basically generate like a structured syntax tree from those tokens. So you can kind of think of the Bicep syntax tree as a hierarchical tree. At the top we have the program syntax, and then inside your program syntax you have the various different pieces of syntax that compose your program. So if you have a resource declaration and an output, for example, underneath your program syntax you'd have a resource syntax and you'd have an output syntax. And then inside those pieces of syntax you then have the kind of nested pieces of syntax all the way down to the tokens. So your resource syntax in this case would be composed of a resource keyword, and then an identifier token, a string token for the actual resource type, an equals token, and then an object syntax, which then contains its own kind of nested pieces of syntax. So the end result of running the lex tokens through the parser is you now have one syntax tree which allows you to view the Bicep file in a structured manner. And I think Marston's going to talk about this at the end, but you'll see quite a lot of complexity with the parser in terms of going beyond just kind of understanding a valid program. We actually need to be able to understand an invalid program as well, because it's, half of the time when you're typing, you're going to have an invalid program. You're going to be missing a terminating bracket, for example, and we need to produce consistent results when that happens. So error recovery that Master's going to talk about is a very important piece of the parser. Okay, so that takes us to the binding phase. At this point, we have our program syntax. The job of the binder is then to basically look over what's being declared in the file and what's being referenced in the file, and we build a symbol table based on that information. So let's say you have a resource called foo, and later on in your file, you're referencing that resource. You're doing foo.properties, for example. The binder is actually going through all of your syntax and basically looking at every single variable reference. First of all, actually, let me just link to the file first. So looking at the file, the first thing we do is we go through and we see what's being declared in the file. So we look for which resources are being declared, variables being declared, parameters, etc. And we build a dictionary based on the name. The next thing we do is we use this name binding visitor, and the visitor pattern generally just allows us to recursively visit the syntax tree. So the name binding visitor is just looking for references to those symbols. So let's say we have a resource called foo. We'd have an entry in this unique declarations dictionary, and the name binding visitor, when it sees a reference to that foo, it's just going to create a symbol for, or it's going to create a reference to that variable. So the end result here is essentially we end up with this list of bindings, and the bindings allows us to go from a syntax, which would be a variable reference here, to the symbol. So it allows us to look at this reference to foo and allows us to quickly say this is a reference to this resource that's being declared in the file. And aside from things being declared in the file, we also do binding for things like built-in functions or namespaces. So if you call the resource group function, for example, the binding is responsible for figuring out which namespace that function lives in and what the the actual implementation of that function looks like. Okay, so that takes us to the semantic analysis phase. We've got a nice dictionary that we can use to look up symbols. The semantic analysis phase does quite a lot of stuff. The first thing I think we do in the semantic analysis phase is type checking. So we look through those symbols. We visit all of the syntax in the document, and we make sure, for example, if you have 1 plus 2, like the plus operator has to operate on integers, for example. We don't allow you to put a string in there. So if we see errors in terms of syntax that's being assigned, then we raise diagnostics for those things. So we kind of, given a piece of syntax, the type checker visits that syntax recursively, checks all of the types of the things being assigned or passed to functions, raises diagnostics for any errors, and kind of bubbles all those errors up to the top. So once you've kind of passed through the type checking phase, assuming there are no errors, you can be pretty confident that your Bicep file is going to compile. Any questions at this point? Okay, I'll keep going. So yeah, again, like this document's published, so you should be able to load this yourself, and you should be able to visit some of these links to see. Oh, that one doesn't work. You should be able to visit some of these links to view these files in your editor. So let me bring up the semantic model. The semantic model is kind of the encapsulation of this semantic analysis. And so when Bicep wants to make sure that a file is valid, we call into this get all diagnostics function, which then calls into assemble diagnostics, which collects all of the diagnostics from the parser. So if the parser found an unterminated set of brackets, for example, that would be a parser diagnostic. It fetches all of the semantic diagnostics, and so that includes performing the type check on the entire program. So that's what this type manager.getAllDiagnostics is doing. So we kind of assemble all of the diagnostics from the different phases before the semantic analysis phase, and use that to drive the decision about whether the file is valid. So in addition to the type manager, we also have the emit limitation of info calculator, which is really geared towards checking limitations of ARM templates specifically. So for example, making sure you don't have two resources with the same name of the same type and the same template. So we also collect diagnostics there. And then finally, we also run the get analyzer diagnostics. And this function call actually collects all the different linters, runs all of those linters over the document, and then collects all the diagnostics from those linters. So at that point, our assemble diagnostics has a list of warnings, errors, info, messages from the file, does some filtering if you've disabled any linters, for example, and then returns that full list. So that takes us to the emitting phase. In the case of the language server, obviously, we've done everything we need to. We can just return the diagnostic immediately. If we're calling through the CLI, then we need to call into the emitting phase. So we need to actually generate the JSON template itself. So the emitting phase, we basically just take all of that information that's been generated by these stages in the compiler that came before us, and we use that to build the JSON document itself. So if I click on this template emitter class, this is kind of the entry point to it. This class itself isn't doing anything particularly exciting, but it calls into the template writer, which then actually assembles the JSON file. So you'll see we call into this generate template without hash method. And here's where we actually start building the template. So we write an opening object bracket. We write the schema. Some of these things should look familiar to you. We write the content version, metadata, parameters, variables, resources. So this is actually the part where we kind of go through all the information that we've collected and we just build that JSON file. And so by the time we get out of this template emitter, we've built our JSON and we've serialized it to a stream or to a file. And then the last thing I just wanted to touch on quickly is the compilation class. The compilation, so the semantic model here is really representing one Bicep file. In the case where you're compiling modules, obviously there are going to be multiple Bicep files at play. So you'll have a semantic model for each Bicep file, and we'll generally compile the children, the modules being referenced as children first, because we then need to use their semantic models to perform validation checks on the parent module. So, for example, we'll check the types of all the parameters, the types of all the outputs, and we'll make sure that the parent module is satisfying these things properly. So the compilation class is really just like the collection of all the different Bicep source files together and the collection of all the different semantic models that have been built for them. So you can use the compilation API to actually kind of orchestrate the kind of end-to-end compilation that the CLI does. Okay, so that was obviously really fast, and happy to discuss further if anyone wants to at a later date. But yeah, any questions quickly before I hand over to Shenglong? Okay, I'm going to hand over to Shenglong.
I had a question.
Oh yeah, go for it.
So you hard code the content version, and you might have told why you do that in previous community calls, but I haven't gotten a gist of it. Why haven't you mapped that to content version that should always be in a Bicep file?
I think that the biggest reason really is just that's something that we have to design. It's a little bit difficult to fit into the kind of like top level, like the Bicep file itself, because generally everything in a Bicep file is composed of declarations. So like, for example, like the closest thing I can think of would be target scope, where we've created this kind of strange syntax which doesn't really fit with much of the other syntax in the Bicep file. So I think the main thing is just that it's something we need to design and we need to understand how it's going to work in the editor itself. It's definitely something that we could do. We just haven't got around to it.
Okay, thanks.
Sure. Okay, Shenglong, do you want to take over?
Yeah, sure. Let me share my screen. And can you all see my screen?
Yep.
Cool. So thanks, Anthony. So Anthony just gave us a very high-level overview of how the Bicep compiler is implemented. So now let's take a look at the code. So to view the Bicep repo, you can just go ahead and visit the GitHub repo and see the source code there. But I would recommend that you just download the repo or clone the repo to your local machine so that you can use an IDE or an editor like VS Code, so that you can get the benefits of features like code navigation. So for this demo, I'm gonna use the Visual Studio. So if you clone the repo, you'll find that there's a bicep.sln file. If you double-click that, and that will open the VS Code Visual Studio solution for the project. So as you open the solution in the Source Explorer, you'll find that there are a bunch of folders. So the folders are used to organize projects. So if you expand one of them, you'll find that there will be a main project and the test projects for the main project, including the unit test project and the integration test project. So
Shenglong, can you zoom in maybe 1 or 2 clicks?
Oh yeah, sure. Is this better?
Yeah, as long as you don't mind panning around like that.
Okay, yeah. Because I don't know how to zoom in the Visual Studio UI, but I'm using a tool called Zoom It. So yeah, so the most important project is the Bicep Doc Core project. We call it Core because it's a library that's shared amongst many other projects, and this is the project that implements the Bicep compiler. So if you expand the project, you'll find that there are many folders and files, which seems pretty overwhelming. So I'm not going to expand all the folders and touch every file because that that might take hours, and I don't want people to fall asleep. So instead, I've created a simplified view of the source tree, which basically outlines all the key components of each individual compiler pipeline step. So for parsing, the most important two classes are, of course, the lexer and the parser. So let me find the parsing folder. So the lexer and parser. So a good entry point of learning how parsing works is to read through the source code of the parser class. So I would recommend that you start with the program method. So program method basically parses a program. When it finishes, it returns a program syntax. The program syntax is basically the root of a Bicep syntax tree. So if you follow the program method implementation, you'll find that it calls other parse method like declaration. And if you go to the definition of declaration, you'll find that it further causes other parse method like parameter declaration and variable declaration. And we've sort of changed the naming convention of each parsing method to be a noun, so they can be mapped exactly to a syntax tree node. Like for example, the variable declaration parse method will produce a variable declaration syntax. And all the syntax nodes are defined under the syntax folder of the Bicep Doc core project. So there are quite a lot of them, but to get started, you should only just you probably don't need to understand every single of them. The program syntax is a good starting point, and that should be good enough. So binding. So the binding classes, the most two important ones are the binder.cs and the name binding visitor.cs. So those are put under the semantics folder. So the binder is pretty simple. It basically wraps the name binding visitor. So the name binding visitor, it basically traverse a given program syntax tree produced by the parser. So let me see if I can find the. Yeah, so you will find that it contains many visit methods. So each visit method will visit a specific program, will visit a specific syntax tree node. And what it does is whenever it sees a declaration syntax, it will create a symbol. So when the binding phase is done, the next step is semantic analysis, just like Anthony mentioned. So for semantic analysis, a good entry point is the semantic model. And all you need to read is the constructor. So this is where all the magic happens. You'll see that it creates the binder, creates the type manager and type checker. It does all the sorts of checking and produces diagnostics. And there's another kind of semantic analysis, which is the linter. So the linter implementation is put under the Bicep Doc core analyzers folder. So the main class is the linter analyzer class, which is driven by a set of linter rules under the rules folder. So the last phase of the compiler is emitting. So for that, you probably only need to take a look at the template emitter and template writer. So I'm not going to show the source code since our time is limited. So yeah, that basically covers the Bicep Doc core project. So there are other projects like the CLI project. So this is basically a console app that implements a set of Bicep commands which you can run in the command line, like bicep build and bicep decompile. So each command is backed by a command class, for example, build command. So this is also a good entry point where you can use to set up a breakpoint and hit F5. So when you debug through the code, you should be able to run through the whole compilation pipeline. So that's the CLI project. Another important one is the Bicep language server. So the language server basically it implements a protocol called language server protocol. So for those of you who don't understand what the language server protocol is, it's basically a protocol that Microsoft developed that can be shared between an IDE or an editor and the language server, which implements, which provides features like auto completion, go to definition, etc. So the core of the language server is a set of handlers. So each handler basically handles a specific language server protocol request sent from the language client. And in our case, it is the Bicep VS Code extension. So I'm not going to touch every handler and explain how they are implemented and what's the purpose of them. But we have created a section in the doc that Anthony just mentioned. So I've created a table that outlined all the purpose of each handler and how they are implemented. So if you're interested, feel free to check it out. So so that's basically the main projects of the Bicep solution. There's another one that I should touch which is the decompiler. So the decompiler is used to support the functionality of Bicep decompile. So if you're interested, feel free to check out the template decompiler and use that as an entry point. So yeah, that basically covers the file structure. And the other thing I want to show is which is not part of the Bicep solution, is the language client, which is the Bicep VS Code extension. And to view the code, I would recommend that we use the VS Code. So the source code is under source VS Code -bicep. Because the source code is in TypeScript, using VS Code would probably give us a better experience. So if you open the project, so the source code is under the source folder, and the core is basically a client.ts file, which defines the language client. And it's actually quite simple and straightforward because we're using the VS Code language client node npm package, which do all the heavy lifting for us. So the language client is pretty thin. And the other component is the visualizer. So the visualizer itself is a React app. When you render a graph, you will launch the React app, and then it will be contained in the VS Code web view. So if you are familiar with React and if you want to contribute, feel free to check it out. So yeah, that's basically the demo for the project structure. So any questions before I hand it over to Marcin? I guess no. So Marcin.
So Marcin, can I jump in? Can I jump in quickly before you go?
Yeah.
And we will, I think we should go over just because we'll have it all recorded. If you need to drop off, that's no problem. But if any of this is deeply interesting to you, to the point where you might actually want to work on it, obviously we take open source contributions, and that's part of the reason that we're doing this. But we also have positions open. So we have a senior software engineering position open. I'm putting the link to it in the chat. If any of you, or if you know anyone who might be interested in it, please do apply. We also have many other positions open that we just haven't been able to get the listing published yet, that are a little more flexible in terms of location and time window. So even if you're in Europe or Asia, there are things that we can do to make it work. And yes, Marcin's right. This is not just working on Bicep. This is the whole deployments team. So if any of you are interested, we would be really excited to expand the team with any of you.
Yep. So let's see if there are any other questions on the chat since we asked. But it looks like we're just having conversations here. So I don't think there's anything pressing. So I guess I'll start my part. So the remaining part that I wanted to talk about is just the design considerations that we usually apply when we're designing new features or just fixing bugs in Bicep. One of the important ones that we've actually learned from our mentors, basically, that worked on TypeScript and C# was effectively we shouldn't really do, like, if there's anything performance sensitive or computationally intensive that we need to do in Bicep, then typically we try to defer that work as late as possible. So we don't pre-compute things that are not needed. Like, for example, when you have and I hope everyone can see my screen, but let's say if you have a Bicep loaded and you're typing something, let's say declare a variable. Actually, let me, what will be the best way? Actually, it's easier with a resource. I'll just pick on DNS zones here. Let's say if I type required properties, but I'm going to clear these things here. Normally in a Bicep file, I could have like hundreds of these resource declarations. And if I want to use completions to figure out what my next properties are, what ends up happening is we do this thing called, we obtain the contextual type for the current node where we're at. And this is a somewhat intensive operation because it has to walk up the tree. In the more like in the worst cases, you may be pretty deep in the syntax tree, and you may have to go up and up and up and up until the top. And if we in a large file, we would have to pre-compute these contextual types or declared types, as we call them, pretty much for every node in the tree. But in reality, we don't really need them for much of anything other than potential just completions. So all we really need to do is compute them on demand and then cache the result. And if someone opens completions again, we can just reuse the work that we've done. And that's kind of the approach that we try to follow as much as possible, just kind of like be as lazy as possible, defer everything until the latest possible moment. And if the computation itself is expensive, then we will obviously just cache the result because we computed it, might as well keep it until it's no longer needed. And as you type every time, the way the language server works is we just throw away everything and recompile from scratch. And that's kind of been holding so far. So the caching isn't persistent for a long time. It pretty much, you type something and then we just clear it up. So memory is really not a concern there. We talked about the error recovery earlier. I said in the chat that this is like probably the most critical feature we have. It's responsible for a lot of parser complexity. Like if you look at our parser class today, let me pull up my Visual Studio. If you look at our parser class today, the parser would be super simple if we didn't have to do any error recovery. But if you look at some of our logic here, I'll just show you as a quick check, like how many references to just one of the recovery functions there are. There's at least 20, 30 references for this particular, oops, sorry, I scrolled too far, for this particular overload. And if you look at like how even parsing a for expression or anything else is we do basically error recovery for everything. And that extends beyond just the parsing. For example, if you type in a variable, let's say if I type a badly formatted expression here, we obviously catch this, that we expect an X, an equals character at this location. But, and I'm going to put in a different name. I'm going to call it foo. And I'll create another variable here, var. And let's say I'm just going to use the resource group function name, and I can just do plus foo. And even though I have a completely, this is a parser error, like the expected equals character at this location is a parser diagnostic with level of error. But even though this isn't a valid declaration, we actually, the semantic model is able to handle the an invalid parse tree or malformed parse tree, and basically create this symbol for the variable, bind it correctly, and it lights up in other places. Like completions will now offer, because of this error recovery that kind of permeates all of our code base. Foo is still available as a variable because the user has typed at least the identifier, even though it has no type, or rather has an error type because we're not able to figure out the type. But of course, if the user finishes it at their convenience, let's say changes it to an integer, which now foo has a type of int that we've inferred. And of course, now we triggered a type error because this is not a valid expression. Similarly, you can have things like a resource that has a duplicate property. Even though we do that, it's kind of it's another type of error they can introduce, makes this an invalid object, but we still treat the DNS symbol as a valid item, and it even shows up here in the outline view, which is powered by our symbol table. Like all of these experiences and the breadcrumbs, I guess I would have to save to show the breadcrumbs. But things like breadcrumbs and other things just works just fine as you navigate through the file, even though you've got tons of invalid content. And I could give many more examples of how this works, but this is what makes a lot of the features that we take for granted possible. The other kind of interesting aspect of our code base is that we tend to design everything to be immutable by default, unless making things immutable is too difficult or too expensive. So, for example, if you look at our parse tree, one of the classes involved in that is like there are many classes that are derived from, if you look at the hierarchy, derived from syntax base. One of these classes is called resource declaration syntax, which represents basically a resource declaration in the tree. And basically the pattern we follow there is you set everything when you call the constructor, all the values are passed in. Sometimes we allow you to have a lower type, maybe enumerable instead of an immutable array. But then we will just convert it into an immutable versions of it. So if you can see here, token for the keyword, which is going to be the resource keyword, the symbolic name identifier, the type, and so forth, are all only support getters. The only setting happens in the constructor. There are also asserts that prevent you from kind of creating trees that are not possible to be produced by the parser. So error recovery makes it possible to have malformed or invalid trees, but that only goes so far. The parser is only able to produce certain types of malformations or whatever you want to call it. And everything else is just immutable. And that serves us pretty well because I have a link in the doc so you can see all the benefits of immutability in general. Actually, it goes to Wikipedia, but gives us things like copy on write, makes it very easy to, when you have concurrent access to the data structures, to not have to deal with concurrency at all, because everything becomes a read, and copy on write makes it much easier. So we get that thread safety, makes it also easy to just pass objects around without having them to be modified under you as you're processing the data. So just simplifies a lot of our code base. Also, with the latest C# features, we can take advantage of something called records, which are basically effectively generate an immutable class in many cases. So that also plays nicely into that. And we, like we said earlier, like we borrowed a lot of these patterns from Roslyn, and if it worked for them, it certainly worked for us as well. And you might have also noticed something strange in my, if you were paying attention. This token here is basically the type of this token here is nullable, but token is not a struct, it's a class. So we're actually using a newest features. There's a feature that they added to C#, I think 8, that allows basically allows the compiler to perform nullability analysis on types, on reference types. Because previously, in previous versions of C#, the classes were basically always nullable. You can always assign a null to a variable that basically was a reference type, was of a reference type. This, when you turn the feature on in the language, and we do this at, I think, we do this at our repo level. I'm going to try to see if I can show this. At the root of our repo, or actually in the SRC folder, if I remember correctly, we have our global build settings, and we basically globally enable nullability in the entire code base, at least in all the C# projects. This makes reference types, like, for example, this token class here, not null, basically stops being nullable. Like if you declare a variable of type token, you will not be able to assign null to it unless you explicitly make it nullable. And there are some helper arguments, attributes that we use as well. But this effectively prevented all null references from null reference exceptions from being thrown in our code base due to bugs and other issues like that. And that feature has paid off for us because we started the code base with it enabled. And that's one of the things that we kind of expect contributors to follow as well. The one other thing that kind of is important to note is that there is I mentioned that the C# compiler will do nullability analysis. So if you look at some of the code, let me find something that will do it. I don't know if I'll be able to quickly find something that demonstrates this, but there's an operator to you can use to disagree with it if you disagree with how the compiler is doing the analysis. It's basically the null. I think it's called the null suppression operator, or I forget the official name. I sometimes call it null suppression operator. But you can basically, if the compiler thinks something's null and you know because of the pattern in the code that it cannot possibly be null, you can basically use the bang to kind of force the compiler to understand it. We don't allow this we don't allow this operator in the code base on the product side. So in the Bicep bits that ship with basically shipped like on GitHub releases, we are not allowed to use the bang operator to overwrite nullability. The expectation is that all the developers will rewrite their code to make the compiler understand it. And there are helpful attributes, like I said, that come with the C# compiler understands. The only exception to that rule is the class that I'm showing here, which basically has a bunch of extension methods that kind of teach the compiler about nullability. So we kind of felt that we had no other choice but had to suppress the nullability here. And of course, the operator is used freely in the code base for the tests. We don't care as much about the tests there because if there's null refs, people won't even be able to check in if they cause test failures. So we felt like the risk was worth making it easier to write tests. But the operator is not allowed in the code base on the product side at all. I think those are the most important design considerations that we kind of require the code to follow. Thread safety is also kind of important, but most of it doesn't really add a lot of complexity here, mainly due to our use of immutable data structures. But there are some pieces that are designed for concurrent access. Mostly it involves APIs that can be called by the language server that is actually multi-threaded. Usually we just throw a concurrent dictionary on most things, and it's worked out so far, but of course other approaches, as long as they're valid, are welcome. And to be clear, these design considerations are kind of both work in progress, and Bicep itself is a work in progress. So you may see examples in the code base that completely violate these principles. And that's possible for various reasons. It's possible that we just didn't get around to changing it because one of the design considerations was introduced after the code was written. And it's also possible that we just made a trade-off between, complexity of the implementation, efficiency, or maybe some other reasons, or just cost of implementation. So there may still be examples, but these are kind of the approaches that I mentioned are just things that we try to do by default. And I think that concludes my part of the presentation. So I wonder if there are any questions in the chat or anything that we could still answer before we kind of adjourn. I haven't been paying attention to the chat at all. Or did I just?
There haven't been questions.
Should do a quiz afterwards to make sure everybody paid attention.
For those who did stay. Any questions on anything else? Cool. Thank you, everyone. Sorry for going over. We will have the video uploaded by tomorrow. Thanks, guys. Have a great weekend.
Bye, everyone.